Hello, grade 10, how are you today? Hope you're doing fine. In this video lesson, we are going to talk about electricity, but to be more specific, about dynamic. So we have been studying static electricity. Now we are going to start a new topic, okay? Dynamic electricity. This topic is going to be a little bit harder because it's going to involve some calculation, okay? So we are going to go slowly. In this video, I'm going to focus on electric current and we are going to do some calculation about current intensity, okay? So this video, we're going to go slowly before introduction about dynamic electricity, then electric current, and do some calculations about current intensity. Okay, let's go. So what's dynamic electricity? We've been studied static electricity. It means like it doesn't move much. It's not in a secret. But in a dynamic electricity, wherever you have electrical charges, they are placed in a circuit, okay? Meaning that the charges can flow in a loop. So the charges flow more freely in a loop, okay? Just like that. When you turn on, for example, a lamp in a battery, this battery like release some electricity and it's gonna move through the circuit. So this we are gonna talk about dynamic electricity and describe all the phenomena related to electric charges in motion. So static electricity, it wasn't in this circuit motion, but now is in this motion, okay? And what's electric current? How do I create electric current? Electric current is the orderly flow of negative charge. Who has negative charge in the atom? The electrons. So who moves to create electricity are the electrons. So I create electric current because who moves are the electrons. So the electrons of conductors in a circuit are constantly pushed from one atom to the next. It's like if you have a group of people and one person is pushing each other. It's how it works a little bit, okay? So the electrons in the conductors, they are constantly moving, pushed from one atom to the next, okay? This force explains the rapid action of electric current. When we turn on a light, for example, it takes some time for this to move, but it's really fast. And the time is like the time for the electrons, all the electrons to push each other. As soon as a current is generated at one point, so when you create a current in one point in a circuit, all the electrons in the loop are set in motion. So all the electrons are set in motion, being felt almost simultaneously in every part of the circuit. So let's say, for example, if you have this representation here. Here, the positive, it is represent what? Remember the atoms? What has positive charge? The protons. So the protons are here, but the protons move freely. Where are the protons? The nucleus, right? So in the nucleus, it doesn't move freely. Who moves freely? The electrons. Electrons has what type of charge? Negative charge, right? So who is moving to create an electrical current is the electrons, not the protons. But here, are they moving in other way? Like all of them are going to the same direction? No, right? So they are moving like in random way. One is going up, other is going down, other is going from left to right, and so on. When I have this kind of movement, I don't have electrical current because electrons are moving in a disorderly fashion. So it's moving randomly in different directions. When this happens, I don't have electrical current. I'm just gonna have electrical current when the movement is orderly. Okay, so when the move is orderly flow, so must be organized. Now let's compare with this second picture here. The electrons, The protons are moving? First question. No, they're stuck, right? Who is moving here? The electrons. Where they are moving? How? What's the direction? From left to right. Just some or all of them? All of them, right? So when all of them is moving in an organized way, I have an electrical current generated. So when electrons are moving in an orderly way, in an organized way, I create electricity. But when it's moving disorganized, I don't have electrical current. Okay? So for me to have electrical current, all my electrons must move in an organized way. They all need to go to the same direction. Okay, so before, because now we have much more knowledge that we have, for example, a century before, but before we didn't understand much about electricity. So the people who were studying this, they create a pattern that we called conventional current direction, that it would be the direction of a positive particles. So it will be from the positive terminal to the negative terminal. But we know now that the positive charge doesn't change, but still use this convention, okay? Even though we know the positive charge doesn't change, doesn't move, but we still use this convention, okay? How it works, this convention? When I illustrate a current, for example, in this circuit here, I always represent my current moving from the positive terminal to the negative terminal, okay? This is for convention. So when we go after, we are gonna do this kind of draw of picture, and then we need to represent always by convention from positive to the negative, okay? So by convention, it was established that the path that a positive particle would take when flowing a circuit. So this would be the pattern of the positive. But we know that the positive doesn't move. It's just a convention, okay? We know that in this case, who is moving is the electrons, not the protons. However, who moves are the electrons, which are negative and not the protons. So here, I'm just representing the same over there, but who is doing this movement are the electrons, not the protons, okay? Even though by convention, I'm putting the representation from positive to negative, we know who is moving actually are the negative charge, not the positive, are the electrons, not the protons. But the real direction of the current is opposite to the direction of the convention. So here you can see that the electron flow is from negative to positive, because who is moving are the electrons. But by convention, okay, convention, we are represent from positive to negative. By convention, we represent the opposite, but in reality, it's gonna be from negative to positive. So you can ask me why? Yes, not the problem, but this is because when they determined this convention, they didn't understand much about this yet. That's why they established this convention and it was accepted. After they figure out it wasn't like that, okay? But then the convention is still there. So you still use this convention part, okay? So keep in mind, what's the convention? Convention is from positive to negative, okay? The direction. But what's the reality? Is from negative to positive, because who moves are the electrons, okay? That's clear. We just need to accept that the convention is the opposite of the reality, okay? Okay, so let's start with a little bit calculation about current intensity. So what's current intensity? Is how much charge. So in the previous slide, I show you that the electrons are moved, but how much? How do I measure this? How do I measure? I call it current intensity. How much electrons are passing through a given point? How many electrons in an electrical circuit per second? So current intensity It's symbolized by the letter I, and it's measured in amperes or A. Amperes, it's the same as coulomb per second. Do you remember what's coulomb? Coulomb is the measurement that I use to measure charge. So if I have 1 coulomb, it's the charge that I measure. Current intensity is how much charge, how many charges I have in a certain point per second. That's why it's coulomb, the number of charge per second, that is the time. So let's explore this a little bit. So 1 ampere is 1 coulomb per 1 second. So a current intensity I of 1 ampere, so 1 ampere, it means that a charge or Q of 1 coulomb flows every second, okay? So over time. So when I say I have 1 ampere, what does that mean? It means that in 1 second, 1 coulomb of charge has passed in that point that I was measuring, okay? So I is what? I is current intensity. So I is current intensity. How I measure in amperes. And what's that? Is the number of charge. Charge, as you remember before, is I represent by Q. And how I measure in coulombs. So current intensity is how many charges in coulombs I have per time. So delta T is time. How I measure time in second. Okay. So we are using the standard unit that is S second. And how do I measure? I can also have an instrument that we called ammeter. This ammeter, this measure the current intensity that's passing through my counter. So counts the number of charges. So this ammeter counts the number of charges. So it tells me how many charges I have per second. So it goes there. In 1 second, it goes like there and count. It's like, for example, you are looking in a street and you are counting the number of cars. Let's say in 1 minute, and you count 1, 2, 3, 4, 5. Let's say in 1 minute now that we are stuck at home, probably doesn't have much. So let's say in 1 minute you have 5 cars. This is the amount of car that you have. Make the analogy with electrons. It's how many electrons or how many charges has passed. So let's say 1, 2, 3, 4, 5 in 1 second. So in 1 second, it passes 5 electrons or 5 charges. Okay, this is what ammeter measure. And how do I say? Instead of say number of cars, I say amperes. So I have 1 ampere. 1 ampere means I have 1 charge in 1 second. Okay, if I have 5 amperes, I have 5 charges in 1 second. And so, okay, let's go now and do some calculation. Okay, so it's gonna be not gonna be so hard as long as you understand what you're doing. So, as we talked in the previous video, first thing, read your problem 1 time. After that, read again and highlight. And after that, we go step by step, following the same steps I talked to you before. So let's read 1 time. Example 1. A 2 millimeters long cross section of wire is isolated and 20 coulombs of charge is determined to pass through it in 40 seconds. What's the current intensity that passes through this wire? So here I have a draw of a wire. In 40 seconds, I know it passed 20 coulombs of charge, okay? So let's read again and get the information. A 2 millimeters long cross section, so I'm gonna write this, is isolated and 20 coulombs of charge is determined to pass through it in 40 seconds. And it's asking me what's the current intensity or I in amperes that pass through this wire. Okay, let's go now to our first step. What's the first step? First step, remember, make a list according to the formula. What are we talking now? We're talking about current. What's the formula for me to measure electric current? I is equal to Q, that's the charge, over delta T is the time. So let's make the list. What's the I? I don't know. It's asking me that, right? What's the Q or the charge? 20 coulombs. It's giving me. And what's the time? 40 seconds. Okay? Do you have anything that I need? Yes. And you can ask me, what about the 2 millimeters? What do I do with that? So now we don't need this information, okay? Because it's just asking me current intensity. So I'm not gonna go over these 2 millimeters, just hold on, leave this. When we move to more complex problems, then we're gonna use it, okay? So don't worry about this right now. It doesn't matter right now because it's just asking me the current intensity and I have everything I need. What's the second step? Check the units and convert if necessary. Remember the units. I measure in amperes. The charge, Q, I measure in coulomb. Is it okay now? Yes. And the time, I need to measure in second. Is it fine? Yes. Do I need to convert anything? No. So in this problem, I don't need to convert anything. Step 3, replacing the formula. So I'm going to write down the formula again, and I'm going to replace. Do I have the Q? Yes. Do I have the time? Yes. So just replace. So for Q, I have 20 coulombs, and for time, I have 40 seconds. So as you can see here, my unit is going to be coulomb per second. But then I can replace this per ampere. Okay? And the next step, simplify and calculate. This one is really easy. So 20 over 40 is going to be 0.5 coulomb per second. And how can I replace this coulomb per second? Is the same as ampere. So my current intensity is 0.5 ampere. So let's do just the full answer. So the current intensity that passed through the wire is 0.5 ampere. Okay, so as answer to the question, what's the current intensity that passed through this wire? Answer, the current intensity that passed through the wire is 0.5 ampere. Okay, really easy? Yeah, so let's complicate a little bit. Example 2. Example 2. A 1 millimeter long cross section of wire is isolated and 2 coulombs of charge is determined to pass through it in 0.5 seconds. What's the current intensity that passed through this wire? So let's read again and now highlight what the information. A 1 millimeter cross long section of wire is isolated and 2 coulombs of charge is determined to pass through it in 0.5 seconds. What's the current intensity that passed through this wire? Now what we're gonna do, okay, current intensity, we need to highlight. First step, list. Let's make a list what we have. The formula is I equals to Q over time. Do I have? No. Q, do I have? Yes, it's given, 2 coulomb. Time, do I have? Yes, 0.5 seconds. What about the 1 millimeter? Do I need this information to solve? No, so just ignore for now. I don't need it. Second step, check the units and convert if necessary. So let's check. My charge is in coulomb. It's okay? Yeah. My time is in second. It's fine? Yes. So I need to convert anything? No. Step 3, replacing the formula. So my formula here, my Q, 2 coulomb, and my time, 0.5 second. And the next step, simplify and calculate. 2 divided by 0.5 is going to be 4 coulomb per second. And what do I do with coulombs per second? I replace by A. So I have 4 amperes. Going back to your question, what's the current intensity that passed through this wire? How do I answer? The current intensity that passed through the wire is 4 ampere. Okay, so this one was really easy. Let's go. Example 3. The datasheet for a car headlight indicates that the light requires a current of 15 amperes. What's the charge needed for 1 minute of operation? Okay, let's read again, highlighting this time. The datasheet for a car headlight indicates that the light requires a current of 15 amperes. What's the charge? What is the charge needed for 1 minute of operation? Okay, so I highlight my main information. What's the first step now? Make a list. So I equals to Q over time. I have the current. Yes, the current is 50 amperes or 15 coulombs per second. What's my charge? I don't know, it's asking me. And the time? 1 minute. Okay, so do I have all the information? Yes. Second step, check the units and convert if necessary. So let's check. My current is ampere or coulomb per second. Is fine? Yes. What about my time? 1 minute. Is it fine? No, should be in second. So 1 minute I need to convert to second. 1 minute is how many seconds? 6 seconds. Okay, so I need to convert first. Step 3, replacing the formula. I have time, but I don't have the charge, the Q. So I'm gonna replace in the right place. So I here 15 coulomb, I don't know the charge, and my time 16 seconds. So don't get confused and put 1 minute because you need to convert first. Step 4, simplify and calculate. So how do I simplify this one? I need to do cross multiplication, remember? So here I do 1 times Q equals to 15 times 60. So Q times 1, Q. 15 times 6. When I do like that, my second disappear because it's going to be divided one by the other and just have left the coulomb. So 15 times 6 is 900 coulomb. Let's go read again my question. What's the charge needed for 1 minute of operation? And how can I answer? The charge needed for 1 minute of operation is 900 coulomb. Okay? One more. What's the current involved when a truck battery sets in motion 720 coulombs of charge in 4 seconds while you start an engine? So read again and highlight the information. What's the current? So it's asking me the current involved when a truck battery sets in motion 720 coulombs of charge in 4 seconds while starting an engine. My first step now is list. Put the formula and the list. The current, don't know. The charge is 720 coulomb and the time is 4 seconds. Second step, check the units. My charge is in coulomb and my time is in second. So, do I need to convert anything? No, it's fine here. Step 3, replacing the formula. So I equal to Q over time. So current is 720 coulomb over 4 seconds. And the last step, simplify and calculate. So if I simplify 720 over 4 divided by 4, I get 180. And what's the unit? Coulomb per second. Then I can replace by ampere. So current is 180 amperes. Let's go read our question again. What is the current involved when a truck battery sets in motion, And how do I answer? The current in the truck battery is 180 amperes. Okay? Okay, finally, the last one. How long does it take for 1 coulomb of charge to flow through a handheld calculator if 0.5 amperes current is flowing. Let's read again and highlight. How long does it take for 1 coulomb of charge to flow to a handheld calculator if 0.5 amperes current is flowing? Now let's make a list and ask me how long. Make a list. I equals Q over time. My I is 0.5. Current is the current, amperes. And my Q is 1 coulomb. And my time? I don't know. I need to calculate. Now let's check the units. Ampere, current is ampere. It's okay? Yeah. Coulomb for charge? Yes. So I don't need to calculate. So my time automatically is going to be in second. Now replacing the formula. What's my current? 0.5. My charge? 1 coulomb. So 0.5 and 1 over time. And the next one, next step, simplify and calculate. How do I simplify this? I can do cross multiplication. Always start with your variable, okay, with your letters. For example, 0.5 times delta t. I'm going to have delta t5 equals to 1 times 1. So 0.5 delta t is equals to 1. How do I do? Is multiply here, go over there, dividing. So delta t is 1 divided by 0.5. What do I get? 2 what? Second. Because if I have the current in ampere and my charge in coulomb, it's going to be my answer in second. So how, let's read again. How long does it take for 1 coulomb of charge to flow through a handheld calculator? So it takes 2 seconds for the charge to flow through the handheld calculator. Okay? So that's it for today. I hope you enjoyed. Please let me know if you have any question, okay? And please answer the questions in the form. Have a great day, guys.